Hey, Math 3 Honors. How's everybody doing today? Hopefully, you're having a good week. These are the new notes. I'm going to split them up a little bit shorter so you're not so overwhelmed with all the notes that I gave you like I did last Friday. So, today we're just going to touch inverses of exponential functions on how they just reverse, and then we'll be done for today with that video. So, here we go. Okay, so if you look at your 3.2.3 notes, it's called the return of the inverse. Them and their tricky little titles. All we're going to be basically doing here is taking y equals ab to the x, and we're going to be doing its inverse. So if you take a look, the first graph is y equals 2 to the x, and I gave you a bunch of points. Notice how in this table, right here, everything reverses in this table. See how it's negative 1.5 here, and now it's 0.5 negative 1 here. 0, 1 here is now 1, 0. 1, 2 here is now 2, 1, and so forth. Okay? When you actually do that, it's called a logarithm. Okay? Notice what it turned into. Y equal 2 to the x is now equals log base 2 of x. And I haven't really talked to you about logarithms yet, so don't worry about that until the next part of this lesson. I just wanted to show you that the inverse, you know how the inverse of a squared is a square root, the inverse of a fourth power is a fourth root. Well, now we have the inverse of an exponent, which we call, there is no such thing as an exponential root. We call it a logarithm. Okay, so just study these two graphs and take a look on how they're complete inverses of each other by flip-flopping the ordered pairs. And I literally just said that. Notice how the points flip-flop. That's because the log graph is the inverse of the exponent graph. Again, don't worry about what logarithm is right now. Just worry about knowing how to flip-flop the ordered pairs. We've been doing this all year, so this really honestly should be no big deal to you. And then I also gave you a quick little table on what the domain and range were of the logarithm and the exponent. Okay, you see the exponential, we have our domain negative infinity to infinity, but with the logarithm, we have 0 to infinity. Okay, this is a little bit different than what you're used to. Okay, negative infinity to infinity is, here's your negative infinity, here's your, come on, draw, here's your positive. But here, notice what's the leftmost side, 0. And then it goes out to infinity. Okay? And then in terms of your range, notice how they're the opposites. Well, they should be, they're inverses. Notice how the inverses, whoops, are the opposites. Well, that's because they're inverses. And if we have a horizontal asymptote in our exponential, which we always do, let me show you that really quick. You know that this right here is my asymptote, y equals 0. Well, look at what happens in its inverse. Now the y-axis becomes the asymptote. That's x equals 0. Here's y equals 0. Here's x equals 0. Oh, that's good. I'm sure you see what I'm doing though. Okay, so realize everything flip-flops. Here's another example of what happens when something is reflected across the y equals x line. Okay, notice how all of the points here did a reverse to get these. Okay, every ordered pair flip-flopped. Okay, here's your exponential function, and then here's your what we call logarithmic function. Okay, so it's a matter of just showing one is the inverse of the other. Now, if you look, it says complete the table to identify the key characteristics of the function. Compare the key characteristics of the function and its inverse. So once again, if we look at the domain of this, I'm going to change colors. If you notice, I don't know, is that going to be any different? Oh yeah, that works. The domain of the exponential is exactly like the way I did it above. Negative infinity up to infinity. Where this one goes 0 to infinity. So it's pretty much going to be the same thing. The domain for f of x is negative infinity. I wanted to keep it in color code. Negative infinity to infinity. My range on this one goes 0 to infinity. Obviously, there are no x-intercepts because the the x-axis is an asymptote. The y-intercept crossed clearly at 0, 1. The asymptote was y equals 0, the x-axis. This one is an interval of increase from negative infinity to infinity. And then, of course, your favorite, your end behavior. Okay, up here, we're looking as x goes to infinity, so does the y. This one over here, as x goes to negative infinity, y goes to 0. I wrote that a little different than we're used to, but that's okay. It should still give you an idea what's going on. Okay, so my end behavior, we have our negative infinity to, God, I cannot do infinity symbols, can I? And then this one is, my end behavior is negative infinity, and it stops at 0. Okay? Your logarithm is almost the opposite of this. Your domain, as I told you before, was 0 to infinity, where your range is negative infinity to infinity. Because up to down, down to up. Okay? Now, if you look at this one, it does have an x-intercept. Well, you can see it right here. This one has the y-intercept. This one has an x-intercept. See how they flip? Okay, that's the idea of what an inverse means. So if I go back to the table, hopefully I'm not making you dizzy. So here, this is 1, 0. Notice the flip. Y-intercepts, there aren't any, because the y-axis is now an asymptote, x equals 0. This is still an increasing function from negative infinity, oh my God, to infinity. Okay, it still does have an increase, comes from the bottom and goes up. And then if you go back to the graph one more time, my end behavior here goes from positive infinity to positive infinity. Okay. And then this one here, I think I made a mistake on the chart, I'll fix it. And then this end behavior over here, as x approaches negative, I'm sorry, said that wrong. As x approaches 0 from the right, it goes, come on, down. Okay, so you got to be careful with that one. That one's a little trickier. Okay, but should be nothing that we haven't learned already. Let's see, go to my, yeps, I did do that. Change that negative to a positive and we'll be good to go. I'm tired today, sorry you guys. So in this one, my end behavior went from positive infinity to positive infinity. As you can see, we did back on the graph on the top there. Okay, went to the right and went up. This one, though, as it goes to the left, it goes toward the y-axis, which happens to be an asymptote. So this one's a little more particular because it's coming 0 from the right and goes to negative infinity. That's the only little trick on this one right here. Okay? Now, believe it or not, this is where I'm stopping today. I need you to understand inverse and end behavior fully today. Okay, so this is video 1. Be nice if I would write that correctly. Let's see, if you go down, I'm not going to worry about that right now. I've already done this for you. If you'd like to fill that in, you could. That's something that I haven't taught you yet. Here we go. For today, you can do a problem like this one. I think that's all you can do today, you guys. You might be getting lucky today and getting a little break. You are. You can only basically do number 1. Okay? So try to get that done and try to catch up on anything you still haven't done on 3.2.2. If you haven't gotten me that formative yet, I'm going to be red flagging it in your grade book, and I'm going to be sending emails home, so let's get her done. It was due yesterday at midnight. If you're so desperate that you still need to turn it in, please send me an email. Have yourselves a great Tuesday.